So previously we learned how to solve triangles using something we call the law of sines. And today we're going to look at another situation where we have a non-right triangle and we are trying to solve it. And we may not have the situation where we have an angle on its opposite side, which is the basis of using the law of sines. So we're going to first off always look for that relationship so that we can set up a proportion between an angle and its opposite side and use the law of sines. However, when we can't do that, we should try and use something we call the law of cosines. Now, the law of cosines can be a little intimidating because the formula is a little lengthy. And when you see me write it out here, I'm going to write it out three different ways. Really, this is the same formula over and over and over again. We will just set it up basically depending on what we have and what we're trying to find. If we have angle A, obviously we would use the first of these three, and if we had angle B, we would use this one, and if we had angle C, we would use this. However, you got to remember, sometimes we might have triangle RST that doesn't have an A or a B or a C in it, so it really doesn't matter. You're just trying to work with an angle and find the sides that correspond with it here. So when we use the law of cosines, because that formula is so complicated, you really need to think of the order of operations, and that is typically where a lot of people make mistakes, is they forget the order of operations when they're solving the equation out and they're piecing things together. So make sure you're following that when you use the law of cosines. After you use the law of cosines and you have an angle found or another side found, you're going to end up having a relationship where you would have an angle on an opposite side. So, of course, at that point in time, we would resort to using the law of sines. Reason being, the law of sines is a little bit more simplistic. It's got things pieced together a little bit better for you to work with, and it's a little faster. But the law of cosines is something we want to use. Now, like I said, a lot of people get intimidated by the formula. The way I try and think about some things is, if you look at this piece right here, it definitely should remind you of something we've previously discussed. So when we continue to work with that piece and we kind of remember that, the other two pieces, or the other piece basically, is subtracting twice the product of these two pieces times the cosine of the angle opposite to this side. And if you just kind of remember this piece and the Pythagorean theorem, it kind of works out. So just kind of keep that in mind as you go through the law of cosines here. Might help you a little bit in remembering the formula. Going into an example, we're going to look at a situation here where we have a triangle with an angle A that's 39.4 degrees. Side B, the angle or the side across from angle B, is 12, and side C is 14, the side across from angle C. And if you try and go with the law of sines here, you'll find, based on what we've learned so far, the angle here, angle A, you would say sine of 39.4 over A would be equal to the sine of B over 12. Now, what that would give you is the sine of this angle here that you don't know, and the length of this side here, which you don't know. So you would have two variables, and that would keep you from using the law of sines efficiently. So what you have to do is resort to using the law of cosines. Now, since we have angle A, we will use the formula going back here, the formula that has angle A in it. Angle A would be used with the A squared equals B squared plus C squared minus 2BC cosine of A. So we'll go to that formula and we'll put those pieces into this formula. So that's A squared equals B squared, which is 12 squared, plus C squared minus 2 times B times C times the cosine of angle A, which is 39.4. And basically, we're just going to piece that in to the formula, and we're going to plug and chug, kind of put the numbers in there and work all the numbers out. 12 squared is 144. 14 squared is 196. 2 times 14 times 12 is 336. And we multiply that times the cosine of 39.4. Now, basically, you're just going to punch that in your calculator. And, of course, to find A, we would have to take the square root of both sides. And that would tell us, when we put all this in, we find that A has a value of 8.96. So, knowing that, we now have an angle and its opposite side. So, we're going to use that to go back and use the law of sines, which is a lot more simplistic, a little bit easier to use. So, we'll say the sine of 39.4 over 8.96. And then we're going to pick the smaller angle, since B is across from this side that has a length of 12. 12 is shorter than 14, so that must mean that B is a smaller angle. And we want to go with a smaller angle, so we'll pick sine of B over 12. And when we cross multiply, we get 12 times the sine of 39.4, excuse me, equals 8.96 times the sine of B. We divide out. Divide by 8.96, and that leaves us with sine B. To find B, we're going to take the arc sine, and that would give us the value of the angle B, and that is a measurement of 58.22 degrees. So we would kind of piece that into our triangle here, and once we do that, we add those two together and subtract from 180, and we find that angle C is 82.38 degrees. But basically, you can kind of see the process that we're going to go through here. We would find a piece using the law of cosines, and then solve the rest of the triangle using law of sines. So that was one example of how we would use the law of cosines. And that's in a situation where we have two sides and the angle between them. We don't have anything, pretty much these two angles and that side aren't there. We can't use the law of sines, so we would resort to using the law of cosines. Here's another example. And remembering, if we can't, we don't have any angles, we're going to have to use arc cosine. And we'll start with the smallest angle. So say we have this little setup here where we have three sides of a triangle. We don't have any angles. Okay, so we can't use the law of sines because I don't have an angle and its opposite side to work with as we were using before. So we have to resort to going down another path, and that would be the law of cosines. Now, what we've set up here is that we're going to use the law of cosines to find the smallest angle first. Now, looking at these sides, our smallest angle would be across from the smallest side, and the smallest side is 19. Again, this triangle is not drawn to scale. This is just kind of something we have there to give us a point of reference. So, angle A is across from the smallest side. So we're going to work with the law of cosines formula that has angle A in it. And that would be this one, A squared, which is 19 squared, equals B squared plus C squared minus 2 times B times C times the cosine of A. And as complicated as that looks, we're just going to kind of start working with these numbers. 19 squared is 361. 24.3 squared would be 590.49. And 21.8 squared is 475.24. And then we go 2 times 24.3 times 21.8 gives us 1059.48 times cosine of A. Now, this is where people tend to make mistakes. And you really need to be careful here, because this is an equation. However, these two pieces are supposed to be multiplied together, and people forget that. So we subtract these two pieces over here to this side, 590.49 and 475.24, we subtract over. So we have negative 704.73 equals negative 1059.48 times cosine of A. And now we're going to divide. So instead of combining these three terms up here, we subtracted these two over first, and then we're dividing. And that's where people forget to make that distinction and remember that these two numbers are being multiplied together. So you have to divide the 1059.48 out of the problem. So we'll do that next, and that's equal to cosine of A. Well, to find A, we would do the arc cosine. So we're going to take the arc cosine of 704.73 divided by 1059.48. And you can kind of punch that in the calculator. You can work it however you want, but you should find that angle A has a measure of 48.3 degrees. So we'll kind of piece that into the triangle. And now you can see that I have an angle and its opposite side. So at that point, you should see that we can use the law of sines. So we'll set that up using sine of 48.3 over 19. And then we're going to find the next smallest angle, which would be angle C, since it's across from the next smallest side. So we would say sine of angle C is equal to 21, or not equal to, but over 21.8. And then we cross multiply. So we have 21.8 times the sine of 48.3 equals 19 times the sine of C. We divide by 19. And then we take the arc sine to get that angle C is 58.94 degrees. Now, once we have found those two angles, we are pretty much in the final stages here, and we can kind of wrap it up by just combining these two and subtracting from 180 to find that angle B is 72.76 degrees. So there you can see an example of a situation where we started off with no angles at all in the triangle, and it wasn't a right triangle, and we didn't know anything about the angles, so we just kind of resorted to using the law of cosines and got some situations where we could apply the law of sines after that. But you always want to start out using the law of cosines in this situation when you can't use the law of sines. And once you get a piece, you're good to go with the law of sines to solve the rest of the triangle. Okay, so we're going to look at some practice problems now. I'm going to go ahead and pull those up on Cami, and we can see our first example here where we have the measure of angle A is 120 degrees, and then we have side B and side C are 9 and 5, and we're going to try and find the measure of angle A so that we can work with this and use the law of sines. Again, our relationship is we want to be able to get this so we can use the law of sines, but I don't have the information there right yet. So I'm going to have to use the law of cosines to move forward. Okay, so since we're looking for side A and we have angle A, we're going to use the formula that we had with angle A in it. And we're going to say A squared equals B squared plus C squared minus 2BC cosine of A. And once we do that, I'll kind of plug those pieces in, and we'll see that we have A squared equals 9 squared plus 5 squared minus 2 times 9 times 5 times the cosine of 120 degrees. Well, once you get that worked out, and you can kind of start working with the numbers individually, or you can just kind of plug it in all at once. But what you're going to have is A squared equals 81 plus 25. And I know I'm writing sloppy. That should be a minus. Let me clear that out because that just looks bad. A minus. That works out to be 2 times 9 times 5 is 90 times the cosine of 120. Now, when you get that and you take the, you work out this value and you're going to take the square root of all of it because you have a squared there, you're going to find that a is equal to approximately 12.3. So we'll go ahead and write that in here. And that is our first measurement. We're going to get that from using the law of cosines. Now, once we have that, we're ready to go with the law of sines. I can just set that up and say sine of 120 over 12.3. And that is a ratio that I can apply to any relationship there. I'm going to work with the smaller angle, and since 5 is smaller than 9, I'm going to say that I'm finding angle C first. So we'll find angle C, and we'll do that by saying sine of C over 5. And like we did with the law of sines previously, we're going to cross multiply here. And I know my writing's very sloppy, and I'm just trying to deal with it. Hopefully you are too. So I have 5 times the sine of 120, and that's going to be equal to 12.3 times the sine of C. And at that point, we'll divide by 12.3, and we will take the arc sine of all of that, and we'll say arc sine of 5 sine of 120 divided by 12.3 is all equal to angle C. So that tells you what angle C is, and you will find that angle C is actually a smaller angle. It's 20.6 degrees, and when you take this angle and that angle, you add them together, that's 140.6, so that leaves over 39.4 degrees for angle B, and that's using the angle sum theorem. So again, we do this work here with the law of cosines. We find one side, and then we just revert back to using the law of sines once we get all this in place. But you have to use the law of cosines first, because you can't use the law of sines with the relationship you're given. All right, so let's go in and look at another example. And you can see in this example, I don't have any angles whatsoever. I just have the 3 sides that are given to me. So since we're trying to find an angle, we're going to look for the smallest angle, and this is the smallest side, so that would mean that angle A is probably my smallest angle here, or not probably, it definitely is. So we're going to use the formula that A squared is equal to 38 squared plus 46 squared minus 2 times 38 times 46 times cosine of angle A. And I'm now realizing I should have put in a 32 here. So that should be 32 squared instead of A squared. So we'll do that real quickly. So I've got 32 squared equals 38 squared plus 46 squared minus 2 times 38 times 46 times cosine A. And now the reason why is that I'm trying to find angle A. So I'm going to work with the formula that has angle A in it. Now, 32 squared, I believe, is 1024. And 38 squared is 1444. Plus 46 squared is 2116. And then I'll just multiply all those three together there. That gives me 3496 times the cosine of angle A. And you should already be thinking, if you haven't thought of it yet, we're looking for the measure of an angle. So you should know that at some point here, by the end of this problem, we're going to be using arc cosine. So what I'll do is I can kind of combine some like terms there that I'm able to combine. Just be careful you don't combine the wrong ones. I can put these two together. 1444 plus 2116 would be 3560 minus 3496 times cosine of A. Now this is where you have to be really careful as you look at this. You're going to look at these two numbers and you're going to be like, man, I should probably just subtract those numbers. They're almost the same number. They're very close to one another. They're pretty much set up just to subtract. So unfortunately, that is not what you should be doing. You should be subtracting 3560 from both sides of the equation. And that is going to be what we do next. And that's going to give me negative 2536 is equal to negative 3496 times the cosine of A. And again, we're trying to get cosine of A by itself. So my next step would be to divide by 3496 and say that negative 2536 divided by negative 3496 is going to be equal to the cosine of A. Now, obviously, like I said, we're going to have to find the arc cosine here. So we'll just, since we're trying to find the angle, we're just going to find the arc cosine of each side. That's that, and then over here we got arc cosine as well. I know I'm kind of writing it sloppy, but you're going to use that and you're going to find that angle A is somewhere around the value of 43.5 degrees. And that's going to be what we use our information off to start off with. Now again, you know, that takes some work, but once we find this is 43.5 degrees, we can go and use the relationship between this angle and this opposite side to set up the law of sines. And that's what we're going to do next. We're going to find angle B, since that's the next smallest angle. So we'll set up our law of sines and say that the sine of 43.5 over 32 is equal to the sine of B over 38. And like always with the law of sines, we start cross multiplying pieces, and we're going to get our equation to be 38 times the sine of 43.5 is equal to 32 times the sine of B. And again, you know, it's a lot of work here. We're solving a triangle. It's kind of like two problems all in one, almost three problems in one. But you can go through these steps pretty simply. We're going to next divide by 32. I know I'm kind of writing sloppy at this point, but we're dividing by 32. And you're going to find that the sine of B is equal to all that. And again, you're finding angle B, so what do you have to do? When you're finding an angle, you got to do the arc sine. So we're going to take the arc sine of all of this, and we'll take the arc sine of that. Again, those two cancel out. We take the arc sine here. So that leaves us with B on this side. And what's B going to be equal to? It's going to be equal to the arc sine of all this together. and that's going to be 54.8 degrees. And again, I apologize for my handwriting there, but hopefully you can see what's going on. If this is 54.8 and this is 43.5 together, we can put those two together and we can subtract from 180 and find that this last angle is 81.7. So when we're given a situation where we have a triangle and doesn't have any angles in it, and we're trying to solve, we would obviously resort to the law of cosines first. And then, like I said before, once we use the law of cosines to get a piece, we get that first piece, and then we can just jump into using the law of sines. Law of sines is a little bit faster, a little bit simpler, not quite as complicated with the formula, but the law of cosine gets us to the point where we can use it. So we want to just kind of keep that in mind as we go through this. All right, that's pretty much all we're going to talk about today, and hopefully you're starting to grasp with this. And if you have any questions, please feel free to contact me either in or out of class, and I'll be glad to sit down and talk to you about some stuff and help you get your questions answered. Have a great day.